for the ZPF method. So for the given question, we will try to solve the answer here. Here given data is, it is in the question it is wrongly specified. It should be here 6000 volts here. Okay, just make a change here. For the, we are solving for 6000 volts here. For 6000 volts here, and what is the rating of the alternator? It is given, already given in the question, that is 2000 kVA. Okay, it is given that 2000 kVA here. For 2000 kVA, now here what is the type of connection? With the armature short circuit field winding, okay, what will you assume that here? We will assume that it is star connected. In the question, we will include that. Okay, in the question it will include that it is star connected. Okay, in the question we will include that it is star connected. Okay, for star connected, we know that V phase equal to VL by root 3. That is 2000 into 10 to power of, it is 6000 by root 3 will give us somewhere 3464.1. Okay, 10. Okay, this is the corresponding phase voltage here. Now again we need to find out the corresponding phase current here. For star connection, I phase equal to IL. We already know that S equal to root 3 into VL into IL here. S equal to root 3 into VL into IL here. From this, we can able to calculate IL. IL equal to S by root 3 into VL. That is S equal to 2000 into 10 to the power of 3 by root 3 into, what is VL here? We got 6000 volts. So what is the corresponding IL or I phase rated current? 192.4 amps. 192.4 amps here. Okay, this is we have written from the value here. Next here, what they is, they have given directly the open circuit characteristics here. Okay, now these values are given to, they have given just 2 points here. Okay, and indirectly, instead of giving that data here, they are given the two values by explaining here. With armature short circuited, that is, it is ISC. Okay, IA short circuit, the full load current flowing through the field current is 17 amps. That means when IA is equal to 0, then IF will be 17 amps here. When IA is equal to 0 from ZPF, for ZPF curve. Okay, when IA is 0, okay, then IA or ISC is 0, then IF is 17 amps. And what is the next thing that they have specified here? When machine is applying a full load of 2000 kVA at 0 power factor, okay, 0 power factor, ZPFC lag, okay, at 0 power factor, the field current is 42.5 amps and terminal voltage is 6000 volts here. So that means they have given one more point here. So when IA equal to 42.5 amps, the voltage is 6000 volts here. So I have to plot these 2 points to get the ZPFC curve here. I need to locate these 2 points to draw ZPFC curve here. Let's try to draw the characteristics here. Before we start the characteristics here, this is terminal line voltage here. Okay, terminal voltage, I have to convert this into phase here. This is terminal line voltage, I have to convert this to phase here. Just to simplify the things, what I am doing here, I am trying to solve directly here. What is 4000 by root 3? 2309.4 volts. This is the phase voltage. The red color one is phase voltage. What is 500 by root 3? 2886.75 volts. Next 6000 by root 3, 3464.1. Okay. Next 7000. 4041.4 here. Next 8000. 4618.8. These are the corresponding phase voltages here. I have to draw the graph for phase voltages only. What are the red color that I have specified here? I have to draw the phase graph for phase voltage only. So now here let's try to draw the graph. What is the scale that I need to assume here? It is the maximum value of voltage is 4600. That is 5000 is the maximum value. So can I take in terms of 10? Okay, in terms of 10 is also okay. Y-axis 1 centimeter equal to 500 volts. Okay, 500 volts. Or else 250 is also acceptable. Okay, to get more better, we'll try to take 250. Okay, x-axis it is voltage. X-axis IF 1 centimeter equal to, what is the value here? The maximum value is 43. So what I'll try to do here, we'll try to consider in terms of 5 amps. Okay. I hope you're drawing the same here. Let's try to construct the graph. This is voltage. So what is the voltage here? I am taking in terms of 250, 500. Okay, so it is 250, 500, 750, 1000, 1250, 1500, 1750, 2000, 2250. So I hope you are drawing the graph simultaneously. Okay, 2500, 2750, 3000, 3250, 3500, 3750, 4250, 4500, 4750. Okay. Okay, this is the y-axis, which is V. Okay, coming to x-axis, what is the scale that I have considered here? 5. So here 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So we can even, instead of this 5 amps here, we can even consider 2.5 also. Okay, to get better clarity, better understanding here. So instead of this, what I will try to do here, so I'll try to change this to 2.5, 5. Even this is also correct. 5 is also correct. But to get a broader, okay, I need to use the complete graph. So and to get the exact values, 12.5, 15, 17.5, 20, 22.5, 25, 27.5, 30, 32.5, 35, 37.5, 40, 42.5, 45, 47.5, 50. This is corresponding IF. I hope I haven't made any mistake. Okay. Now here, let's try to locate the points here. So help me in locating the points. First, we'll try to draw the OCC. For 14 amps, what is the voltage here? 2309.4. For OCC, the characteristics are okay. First 14 amps. So it is 14 amps here. 14 amps. So here, yeah. For 14 amps, what is 2309, 2300, approximately 2300. So this is the corresponding point here. 2309. Okay. We have to okay. So I will do the same. You can submit the same for assignment questions. So 23. So 2309. And what is the corresponding current here? Here it is 14 amps. And next one is for 18 amps. What is the voltage here? Phase voltage 2866. Okay. Help me. Someone help me with the values here. For 18 amps, what is the voltage here? 2866. Am I correct? Okay. 2886 for 18 amps. For 18 amps, it is 18 amps. 2886 approximately. So as I'm using the tab here, so it is 2886 here. This is the next point here. Next one. What is the next point here? For 23 amps, 3464. For 23 amps, 3464. 23 amps, 3464. Okay. Next one is for 4041. The current is 30 amps. For 30 amps, 4041. So you cannot draw exactly, but try to draw approximately at least 4041. 4041. Next for 43 amps, it is 4618. For 43 amps, 4618. 4618. Okay. So combining these, we can able to get the OCC characteristics here. Okay. Combining this, we can able to get the OCC characteristics. I hope it's done fast. Okay. Combining this, we have got the OCC characteristics. Next, for ZPFC, what is given here? When IA equal to 0, we have to draw one more IA versus ISC. Okay. ZPFC, V versus IF. Sorry. Okay. We have to for ZPFC, we can have to draw V versus IF characteristics here. For this, when normally for pure inductive load here, when IA equals 0, under short circuit, what happens here? What is given in the question? With armature short circuited. With armature short circuited. When armature is short circuited, what happens here? Voltage is 0 or not? When there is a short circuit, under short circuit condition, voltage is 0 and current is, listen here. When under short circuit condition, voltage is 0 and current will be maximum here. So indirectly is giving that voltage value is 0. So locate the point here. When voltage is 0, and let me try to take one more color here so that it will be easy to identify. So for IF equal to 17 amps, voltage is equal to, for IF equal to 17 amps, voltage equal to 0, not current here. For IF equal to 17 amps, voltage equal to 0 here. 17 amps. This point, okay, which I am representing with green line. Okay, for IF equal to 17 amps, voltage equal to 0. Next one is for IA equal to, okay, for IF equal to, sorry, it's not IF, for a field current, okay, I'm sorry, here, for a field current of 42, for IF equal to 42.5 amps, what is the corresponding voltage here? 6000 volts here. So again, this voltage has to be converted into what? This is line voltage. We have to convert into corresponding phase voltage. That is 6000 by root 3. Again, we will get 3464.1 volts. 3464.1. Okay, 3464. Okay, they have in the question they will only specify line voltage, and we have to convert that into phase voltage here. Okay, so 42.5 for a field current of 42.5. For a field current of 42.5, what is the corresponding voltage here? 3464. 3464 here. Okay, for a field current of 42.5, the corresponding is 3464. Now what you have to do here? Normally they will give the data for ZPFC. Sometimes they'll give in terms of sentences, they'll give two parameters. You are not supposed to draw a straight line because the characteristics are similar to this OCC here. Okay, so that in you have to draw approximately in a curve manner. You have to draw the characteristics like this. Okay, this one is ZPFC characteristics here. Okay, this one is ZPFC characteristics. Okay. This one is ZPFC. If you are unable to follow, if you are stuck, just listen and you can do it later. Okay. This is we have drawn OCC as well as ZPFC characteristics here. Now what we are supposed to do here, as per the steps of procedure, first thing, what is the first thing that we need to do here? Draw dotted rated voltage. Represent dotted rated voltage here. What is the rated voltage here? We got 3464.1. So it is given in the question that is 6000 volts line voltage. We have to convert that into phase voltage. What is the rated phase voltage here? 3464.1 here. So use a scale 3464.1 here. So approximately I am considering here V phase rated. Draw a dotted line, that is 3464 point onto where? I'll try to use different color. Okay, this point, okay, let's assume that this is O, this is A, and I am considering this point as B here. Let's try to do it fast, as we already solved previous one problem and we have explained in detail here. So now whatever the OA length is there, OA length in terms of centimeters here, try to measure the OA length here, 1, 2, 3, 4, 5. And what is this point is, it is 17 amps. 17 amps. So what is the corresponding centimeters? Length 6.9. Yeah, okay, it is approximately 6.9 or 6.8. Okay, same 6. Okay, whatever the length, whatever the scale length is there, 6.8 centimeters. We have to draw from here. So same, take the same scale length here. So 1, 2, 3, 4, 5, 6, 6.8. So I'm considering this point is approximately here. This point, I'm using a different color here. Okay. This point, this is the length. This give the notation as C here. This BC length is must be equal to OA length here. Okay. From point B, draw a line, horizontal line, such that BC length is equal to OA length here. Okay. BC length is equal to OA length. Next, after this, what I am supposed to do here? We are supposed to draw a tangent to air gap line to OCC line. So what I will do here, draw OCC line such that it touches the maximum portion. Draw tangent OCC in this air gap line such that it touches the maximum portion. It touches the maximum portion. Okay, it touches the maximum portion. That is without saturation. This is how the generated voltage will be there. Without the saturation, the generated voltage will be like this. Next. Okay. Now from point C, what I am supposed to do here, from point C, draw a line such that from point C, draw a line draw a parallel line such that it should be parallel to AG line, such that it intersects the air gap line, such that it intersects the OCC line here. Give the notation as some D. Give the notation as D here. Okay. Give the notation as D here. Once it is done, we have to join BD and draw a straight perpendicular line here. Draw a BD and draw a straight perpendicular line. Give the notation as H here. Okay. So what is this length here? This length is, I'll try to write here, DH length is IAXL drop. Okay. BH is IFA. Field current required to compensate armature reaction effect here. What about CH? CH is IFL. field current required to compensate the leakage reactance drop. Okay, IFA as well as the other one is IFL. Okay, now for A, we already discussed that ZPF method. In ZPF method, we are considering both XL as well as XA separately. We are considering both XL as well as XA separately here. So what I am doing here by using EMM method concepts, I am considering XL here and as well as by using MMM method concepts. Okay, I am considering XA so that ZPF will be more accurate. Percentage voltage regulation will be more accurate here. So in EMF method, what is the formula here? Okay, we have this ER. I am considering it as intermediate value. ER formula is equal to under root of V phase cos phi plus IA into RA whole square plus V phase sin phi okay, V phase sin phi plus or minus IA into XL whole square. In the question it is given as lagging load or leading load. It is given as 0.8 power factor lagging. So the question will be it is plus only. Okay, the question will be it is plus only. Simply substitute the values. Let's do it fast. Okay, so it is, what is V phase here? Quickly tell the values here. It is 3464.1. Am I correct or wrong? 3464.1 into, what is cos phi here? 0.8. IA value is, what is the phase current, that rated phase current that we got here? 192.4. 192.4 here. 192.4 into RA, we got given as 2 here, whole square plus V phase sin phi 3464.1 into cos phi is 0.8, sin phi will be 0.6 plus IA into XL. This length has to be collected from where? From the graph here. This length has to be selected from the graph here. So take the difference of these two, or measure the length and multiply with scale here, whatever it is convenient for you. How many boxes it is covering? So here my case 1, 2, 3, 3.6. What about you? As you are doing the exact graph, how many? 3.4. No, okay. So I'll approximate it as 3.5 centimeters. Okay, 3.5 centimeters into, what is the scale here? 250 volts. So 3.5 centimeters into, to measure this, I am writing separately here with separate. Okay, IAXL equal to 3.5 centimeters into, what is the scale here? 250 volts here. So approximately it is equal to 250 into 3.5. So it is 875. Am I correct? 875 volts. Is it okay? 250 into 3.5. What is the answer? $875. So I am taking this value IAXL, where this IAXL will be useful here. We will use this IAXL in the EMF method formula here. So that is 875. Boundary I am writing separately so that you can understand this. Okay, 875. Okay, and can you simplify and tell me the answer? 4322.47. Let's confirm this answer. Any second answer? Just speak. Okay, 4322.847 or 87? 47. So this is the ER value. This is not the final value. This is intermediate value which we got from the EMM method. So that means I am only considering the leakage reactance. Now what I have to do here, whatever the ER is there, that is 4322.47 volts, I have to represent on OCC graph. Okay, on y-axis. Okay, and from that extrapolate on x-axis to find which parameter? Corresponding field currents. That is, I am saying that IFR here. So whatever the 4322.47, let's try to represent here. Okay, what is 4322.47? Am I correct? Yeah. So 4322, approximately it is 4322. I am locating this point as this one as ER. This point as ER here. Okay. So draw a dotted line. Okay, dotted line onto where? Draw a dotted line, horizontal dotted line onto OCC such that it intersects. Draw a dotted horizontal line onto OCC. What are the intersection point that I am getting here? From that, draw a dotted vertical line. Draw a dotted vertical line onto IF. This current I am calling it as IFR. This current I am calling it as IFR. What is the current that you got here? 35. Any other answer? 35. Okay. So as I am using the tab, I will confine with the answers which are used in the graph here. This IFR is equal to 35. Okay. So how am I directly getting this value? How I am getting this value here? What are the ER value? What is ER value here? 4322.47. This value I am representing on the y-axis. From that I am drawing a dotted horizontal line onto OCC. From the intersection point, draw a dotted vertical line. And what are the corresponding field current that is there? That will be the IFR current here. So what I got here? This IFR value is 35 amps here. This IFR value we got is 35 amps here. Next, now I will try to implement this MMM method. So MMM method indirectly means I am considering XA here. So in MMM method, what is there here? We have to do the phasor sum of IFA and IFR. The resultant will be IFT here. What is the corresponding formula here? IFT equal to under root of IFA whole square plus IFR whole square plus 2 into IFR cos of 180 minus plus 5. I am not using minus because it is just for the lagging load here. What is the IFA length here? We need to calculate again from the graph. What is IFA length? 1 centimeter. 1, 2, 3, 3.8. 3.5. Any other answer? From the graph, what is the IF length? That is, what is the BH length? How many centimeters it's covering here? 3.4. 3.4. Each centimeter covers how much amperes? 2.5. So that means, so let's try to write again here. So I am writing here IFA length equal to 3.4 centimeters into, what is the scale here? 2.5 amps here. What is the value here? 3.4 into 2.5. 8.5 amps. I am not supposed to take directly 3.4 in the formula or directly, because that is just a length, and each 1 centimeter covers how much angle, how much amperes here? 2.5 centimeter, 2.5 amperes. So for that reason here, this IF length has to be calculated from the graph. Okay, from graph IFL length, which is equal to BH. Okay, which is equal to BH here. So let's try to substitute these values here. What is IFT value here? IFA value here? 8.5 whole square plus, what is IFR here? We got 35 whole square plus 2 into 8.5 into 35 into cos of 180 minus, what is the cos of 180 minus 90 plus, and similarly what we are supposed to phi equal to cos inverse of 0.8. What is the answer here? 36.86 degrees. So plus 36.86 here. So by simplifying, what will you get here? IFT as first under root of 8.5 whole square plus 35 whole square plus 2 into 8.5 into 35. This is completely one block here. 40. Let's try to confirm this answer. 40 point. Okay, 40.67. This is the final field current here. Final total field current here. Now what I'm supposed to do here? Okay, I have to locate IFT on x-axis. From this, draw dotted line onto OCC. Okay, draw dotted line onto OCC. Okay, from this, next, and after that, then they extend dotted line, extend dotted horizontal line onto y-axis, and that point will be E0 here. Simple conclusion. Okay, so what is the corresponding current we got here? 40.67. Okay, 40.67. Okay, so I'll try to use red color here. 40.67. Okay, this is the IFT. Is this clear or not? 40.67 amps here. From this, draw dotted vertical line onto where? OCC. You will get a point here. Draw a dotted vertical line onto OCC. Okay. From this, again, what I am supposed to do here? Draw dotted line onto y-axis. This point is E0. This point is E0. We have solved as per the values that substituted and got. Okay, this point is E0. What is the E0 that we are getting now here? Sorry. I made a small mistake here. I'm using this ZPFC. Okay, yeah. So we have to draw a dotted line onto OCC. It is a bit confusing in tab here. Okay, so this is the intersection point onto OCC. From where we have to draw a dotted line onto y-axis. This voltage is the E0. So approximately, what is the voltage that you are getting here by SOLN? 4500 exactly. Okay. So any other answer? So here we can able to locate it 45 voltage here. So what I am doing here, from the corresponding to the 40.67, corresponding to 40.67 amperes, I am getting the intersection point as this 4500 volts, 40.67, and the corresponding E0 will be 4500 volts. Ultimately, what I am getting here, no load voltage. This E0 is no load voltage. Once this is get, what we are supposed to do here, we have to calculate percentage voltage regulation. That is E0 phase minus V phase by V phase into 100 here. What is the E0 phase that we got here? 4500 minus V phase. What is V phase here? 3464.1 here. 346.1 minus 346.1 into 100. So answer is 29.9%. This is for lagging loads. This is how we have to calculate percentage voltage regulation by using the POTIER triangle method. This is compulsory 10 marks question. You can expect theory as well as numerical. There are only two options here. Either they will give the complete data for ZPFC, or else they will just give the sentences. Like we already solved one problem with the complete data. This is sentence formation here. So only thing is the way you draw the air gap line, the way you draw the OCC, the way you draw the ZPFC and locate the point. From that the values will slightly change. Okay.